All right, good morning, good afternoon, wherever you are. I hope you are doing great. Taking a look at what we're going to be looking at today, we are going to be talking about the point slope form, okay, which is kind of an addition to what we talked about yesterday. But before we get going with that, I would like to first of all take a look at this problem right here and say, okay, hey, I'm not going to give you any information, and I just want to see if you can figure out the answer to it, okay? And so as we look at this problem, we have a point which is at -1, 4. So if I go -1, +4, 1, 2, 3, 4, place my point right there, okay? And then I go with the slope of 3. Again, remember, rise of 3, run of 1, 1, 2, 3 over 1. 1, 2, 3 over 1. I can even go down 3 over 1, down 3 over 1, okay? And so this line right here is the line that we are talking about for this problem. And so as I look at that, if I go ahead and write this out, we want to get this problem into the slope-intercept form, what we talked about yesterday. And so remember, the slope-intercept form says this: y will equal the slope times x plus the y-intercept, okay? And so as we look at this problem, it's real simple because we already know the the slope, okay? And the slope is going to be a slope of 3. So y equals 3x plus, and where does it cross the y-axis here? I can go up 1, 2, 3, 4, 5, 6, 7 right there. So y equals 3x plus 7 is actually the answer we're looking for, okay? And so the question then becomes, well, what is it about this point slope form? What is the equation and how does it make it easier for me? Well, if I go down to my slope problem down here, I want to fill in some things. And so when I think of slope, and I'm pretty sure when you guys think of slope, you think of this, rise over run, okay? Usually the first words out of students' mouths when we're talking about slope, rise over run. And then I ask the question, okay, what's the equation? And I always get this, I don't know, ooh, I can't remember the formulas, I can't remember. Let's make it real simple. On the coordinate plane, when we're talking about the rise, what are we actually talking about? We're talking about the displacement of the y values. I know that was kind of a big word. The change in the y values, okay? How much from one y value to another y value does it change? That gives you the rise, okay? And if we're talking about the run, okay, the run would be this direction here, okay? How much does it change in the x values, okay? All right, if you've seen this symbol before, that's called delta, and that'll tell us what mathematical operation we want to do here in a second, but it's the change in the y's over the change in the x's. Change in the rise, change in the y's, kind of rhymes, right? Over the run, the change in the run, which would be the change in the x's. So if you think about it here, if we're changing the y values, that's going to be subtraction. So it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? And whatever you get out of that, that will equal our slope. And like we talked yesterday, slope is the m. The variable used for that is going to be m, okay? So then the question becomes, okay, I thought we were talking about point slope form, not just slope. Well, the point slope form is actually born out of this equation right here. So if I look specifically at this equation, and I go ahead and I want to cross multiply here, okay? When I cross multiply between these two, if I multiply these two here, what you get is going to be y minus y sub 1. You notice I got rid of the y sub 2, the sub 2 part, because if you were to look up this equation online, they don't have the sub 2 part, and it doesn't really matter with this problem, okay? I'm just getting rid of one of the subsets. If I cross multiply this way, I'm going to get m parentheses x sub 2 minus x sub 1. Okay, oh, I should have got rid of the subset there. We don't really need that subset, okay? And that is what we call the point-slope form. Now, to kind of prove it to you guys that we can use this equation, let's go back to the first problem up here where we said, okay, I know what the equation is going to be. We said the equation was y equals 3x plus 7. And I'm going to use this formula, so let's write out the formula that we just came up with. Y minus y sub 1 equals m parentheses x minus x sub 1. Okay? I'm going to use this point, negative 1, 4, and that slope of 3, and plug it in for these values. The first value is the x value. X comes before y in the alphabet, so is it in the coordinate plane. And this is my slope right here. That'd be m, sloppy m there. Okay? So as I plug this in, we get y minus the y value is equal to the slope, parentheses, x minus the x value, which is negative 1. Okay, you'll notice the double bracket that I put there, the one around the negative 1, and that's because I don't want the negative that's here to get confused with the negative that's there. Okay, and so those are two separate things. Make sure you have that there. Now, from there, we just want to solve for y, because remember, this slope-intercept form, it has y by itself. So what am I going to do? Well, I'm probably just going to make my double negative positive, and then I'm going to distribute this 3 into the parentheses there. So y minus 4 equals 3x plus 3. Okay? Again, still doesn't look like our final equation, but a little bit closer. Well, to finish this off, plus 4, y will equal 3x plus 7. 4 plus 3 is 7, voila. Now we know we've done it correctly. Okay? So the question probably ensues, well, why would I need to know the point-slope form? And I think the best answer for that, there's two answers I would give you. One would be if the graph is off the coordinate plane. Okay? If it's way up there, you're going to need to have the point-slope form memorized and know how to use it. The other thing is this. What if it doesn't cross right at a grid line on your coordinate plane? What if it's like y equals 3x plus 1/7? Okay? It's really hard to estimate 1/7 on a coordinate plane as opposed to doing it algebraically. So that would be my answer for why you need to know the point-slope form. Okay? All right, now, what I'd like you to do, you see the next example down here where you've got the point, which is at 2, negative 4, and the slope of negative 1. I'd like you to pause your computer and work this one out. Okay? When you're done and you think you have the correct equation, turn your computer back on and double check it with me. Okay? All right, hopefully you did your work correctly, but let's double check here. Let me go ahead and put down the equation one more time. I always like to rewrite things because it helps me memorize. I don't know if you guys are like that, but the more times I can write things down and talk them out, the more likely I can memorize it. Again, this is my x value. This is my y value. Okay? And so as we plug these in, here's what we have. We have y minus, hopefully you didn't forget, parentheses negative 4. Very, very important, the parentheses there. The slope is negative 1, parentheses x minus x sub 2, which is, or x sub 1, which is going to be 2. Okay? All right, now, probably after that, I'm going to go ahead and say I've got a double negative, make that positive, and I'm going to distribute this into the parentheses there, solve algebraically for y. So y plus 4 is equal to negative 1x plus 2. Okay? And then from there, again, to solve for y, I'm going to subtract 4. And so y will equal negative 1x minus 2. Okay? Now, you may be thinking to yourself, well, Mr. Couples, how do I double check this? I mean, there's a lot of steps in there where I could have maybe placed a number in the equation wrong, or maybe I did some algebra wrong. Well, here's my answer to that. If I go ahead and graph this equation of this line, y equals negative 1x minus 2, doing my y-intercept first, -1 slope. I can either go up 1, +1, -1, +1, -1. Okay, or I can do -1, +1. Either way, I have a -1 slope. Okay, I can do that. I can graph that line right there. Okay, and then I can ask myself, is this point on that line? Does this line have that slope? Now that part's easy because I've already got the slope correct. Okay, but looking at the point 2, -1, 2, 3, 4, well, we see that that point and that slope is part of that line, so therefore this equation is correct. Okay, so important to not only know how to graph it, you also need to know how to use the slope-intercept form. All right, so where can I go from there to make this a little bit more difficult? Well, I can take some of the information away and make you solve it from there. So looking at this next problem, it says determine the equation of a line in the slope-intercept form, so just like we did in the first one, if you're given only 2 points on the line. Okay, so again, you can graph those 2 points out over on your coordinate plane and probably figure it out, but I want you to practice using the slope-intercept form. So the question then becomes is this, sorry, not slope-intercept, but point-slope form. The question then becomes this, what part of the point-slope form don't you have? Well, you have 2 points actually instead of 1, but you have no slope. Well, that's pretty easy. You can figure out the slope. So if I go ahead and do my slope formula, I'll go ahead and do x sub 1, y sub 1, and x sub 2, and y sub 2. Okay, sorry for the sloppiness there. All right, so if I plug that into my slope formula, the slope is going to be this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that was a 10, that last number. I know it's really sloppy there, but that's a 10. Okay? -2 minus 2 gives me -4. 2 minus 10 is -8. A negative divided by negative is a positive. 4 divided by 8 is 1/2. There's the slope of my line. Okay? Now from here, I've got my slope, and I've got 2 points. So which point do I use? And the answer is it really doesn't matter. And I'm going to try to show you both of those here. Okay, so if I go ahead and take A, let's use point A and the slope of 1/2. So if I plug it into my point-slope form, it'll be y minus y sub 1 is equal to the slope, parentheses, x minus x sub 1. Okay? And then from there, I just need to solve for y. So y minus 2, I distribute the 1/2, so 1/2 x minus 5. And then if I add 2, y equals 1/2 x minus 3. Okay? All right, so that would be the equation of that line. Now, if I have done this all correctly, I should be able to take that same slope of 1/2 and this point at B and get the same equation that we did previously when we used point A. So if I do that, let's look at this. Y minus, this time it's y sub 2, but it's the y value there. Again, notice the parentheses there for the double negative. Is equal to 1/2 parentheses x minus the x value. Okay? Now it's just an issue of solving for y correctly. So if I change that double negative to a positive, we have y plus 2 is equal to, distribute that 1/2, 1/2 x minus half of -2 is going to be -1. Okay, so again, that's minus 1 out there. It doesn't look like it, but it is. And then I'm going to subtract 2 from both sides to get y by itself. 1/2 x minus 3. Oh, we got the same exact equation on both sides, okay? For all of these, I would like you to go ahead and graph those out for me. I just think that it's good practice to get in the habit there. Again, we can always prove to ourselves that those 2 points are on that line. So if I do that, -3, 1, 2, 3, and then I do the 1/2, up 1 over 2, up 1 over 2, 1 over 2, up 1 over 2, 2, down 1, left 2, 2, 2, 2, 2. Okay. So then the question would be, again, this is back to my graph here. The question I would then ask is, about tripped on a cord and knocked off my computer. The question I would then ask is, are these points on this line? So if we go out here at, can I get that to minimize? There we go. Okay. 10, +2, right there. That's good. Okay. If I go to 2, 2, -2, I'm good right there. Okay. So again, that's how you would do those. So what I'd like you to do over the next couple of minutes, you see we've got one last problem down here, 2 points, points C and D, and I'd like you to go ahead and use the algebra here. I want you to use the point-slope form and see if you can come up with the equation. Pause your computer for me, and once you're done with that, come back to me and we'll see how you did. Okay, now that you're back, here's x sub 1, y sub 1, x sub 2, y sub 2, and I'm going to plug that into my slope formula. So my slope formula is going to look something like this, 4 minus 7, and then 3 minus 2. Okay, now I always get this question every year, what if I switch those? 7 minus 4. 2 minus 3. Guess what? It's going to be the exact same thing. We can even show that here. 7 minus 4, 2 minus 3. Up here, 4 minus 7 is -3. 3 minus 2 is 1. So the slope is a -3 slope. Here we have 3 over -1. A positive divided by negative is still negative. So we've actually got the exact same slope there. Now, what you should have done from there is use that slope with one of these 2 points. What I'm going to do here, I'll do both equations. If you only did one, you can check it to make sure you've got the same final answer there. So if I use C, it's going to look like this. Y minus 7 is equal to -3, parentheses, x minus 2. Okay. If I use D, it will look like this, y minus 4. Yeah, just making sure on that previous one, is equal to the slope, which is -3, x minus the x value, which is 3. Okay? So as I work this out, I'm going to distribute that -3 there. -3x plus 6, double negative makes a positive, and then we're going to add 7 to both sides. Y equals -3x plus 13. So this one obviously goes off the grid there, and so using the algebra is probably more precise because you'd have to continue to use your tick marks to go up the line. Okay. This one right here, y minus 4 is equal to -3x plus 9. Okay, negative times negative is positive, so that's why I get +9. I'm going to add 4 more. So y will equal -3x plus 13. Okay, we got the same equation. We're good to go. Okay. So again, hopefully that was all made sense to you. You can go ahead and graph it. If you have this type of problem on the homework, don't be afraid to go ahead and use some extra tick marks there. Just try to be as precise as possible. So, if you have any questions, let me know. But I hope that made sense. I'll talk to you later. Have a great night. Make sure you get your homework done. Goodbye.